question asks us to provide an arrow pushing mechanism for this reaction. The first thing that will happen is that the water will get protonated by sulfuric acid. So we'll take a lone pair of electrons on water, and we'll use those lone pair of electrons to grab an acidic hydrogen from sulfuric acid. That will form hydronium ion, H3O+. And we'll use H3O+ to protonate the alkene. The alkene can be protonated. We can take the electrons from the alkene to form a new bond with hydrogen. That will form a Markovnikov carbocation at the most stable position. That would be the internal position here. We can also show this mechanism using curved arrow notation, where we take the electrons in the pi bond, we bounce them through the terminal carbon to form a bond with the hydrogen. This arrow says that we break the electrons stay with the terminal carbon to form a new carbon-hydrogen bond at the terminal position, and we take the electrons away from the internal carbon to do so, leaving behind a carbocation at that internal position. Our new carbocation then would form at that internal position. This is a secondary carbocation. It is next door to a tertiary position, however, so we can further stabilize this molecule by doing a hydride shift, where we shift that hydrogen over one carbon to form a new, more stable tertiary carbocation. That tertiary carbocation can react with water. Water, using a lone pair, can react with that tertiary carbocation to form a new oxygen carbon bond. We don't have any arrows showing the breaking of any of the oxygen hydrogen bonds though, so oxygen will still be bonded to all of its hydrogens, meaning it will still have a positive charge. Finally, to neutralize this product and get us to neutralize this intermediate and get us to our final product, we'll use some more water to deprotonate one of these hydrogens to neutralize the product, and that will form our desired product after carbocation rearrangement.